Hey everyone, so today I'm going to be telling you more about electric circuits, this time focusing on the symbols, okay? So, here are some symbols that you will find, possibly that you will find in a circuit, and I'm going to go through them and what they do, okay? So the first one is a cell. Now the cell is kind of in a lab, for example, is the same as the power pack, so it's what gives the energy that needs, the electrons need to go around in a circuit. Many people confuse the cell with a battery. I have a picture of the battery later on, but a battery is if I have more than 2 or more cells together. This is the positive end and this is the negative end, by the way. The next one is a switch. In this case, that switch is open, okay? The switch enables the current in a circuit to be switched on or off. This is because the current needs, or the electrons actually, saying better, need to have a place where they can go. And if you have a gap in the circuit, the electrons will have no way to go or nowhere to go. So a circuit with a gap is then a circuit that is not going to work. So you need a complete circuit in order to get electricity flowing, okay? Next one is a light bulb. Sometimes it's called an indicator, okay? And it emits light when the current passes through it, okay? The other one is a diode. More on the diode in just a couple of slides. So the diode is a device that allows the current to go only in one direction. What I normally say is that, see this arrow in here? That's the direction that the current can pass through. So if you are in the direction of the arrow, the current can pass through. If you get the diode the other way around, it meets this part, which I call a wall, and the electrons cannot pass through, okay? So if it goes in this direction, is the forward biased or forward direction. If it's the other one, you say the reverse direction. Now the next symbol is really just like a diode, but it emits something. There are 2 arrows coming off. That is an LED, a light emitting diode. So it emits light when the current passes through it in the direction, in the forward direction, okay? And you know all about LEDs because you have it at home, right? Next one is an ammeter. So you use it to measure the amps. So it's an amp meter. So you measure the electric current. That one is going to be a resistor, is a fixed resistor. So it has a certain resistance and that resistance does not change. A resistor, as the name says, resists the current. So the higher the resistance you have, the lower the current you will get, okay? The symbol next is just like the resistor but with an arrow, okay? So that is a variable resistor, which allows the amount of resistance and therefore current to be varied. The other one has nothing to do with resistors. It kind of looks as well like these resistors, but it has a line going through, okay? And this line is to represent the metal wire that they are made of, and that breaks. Is a fuse. A fuse is designed to melt and therefore break the circuit if the current through it is greater than a certain value. There's going to be more on fuses later on. The next one I don't quite see coming often. Someone didn't take the register. I don't see this one coming that often in tests or exams, but it's a heater, okay? So again, it is designed to transfer electrical energy to heat the surroundings. And the last one, look, it's just like an ammeter, but it has a V. So it must measure something that starts with a V. And if you saw my last video, there is this thing called volts. So it's a voltmeter, which measures either the voltage or the potential difference, okay? Now, this particular picture, by the way, is from AQA, all right? So these diagrams, they are from the AQA or then from the internet that I found, okay? So they are not mine. So, other ones that we haven't mentioned. So we mentioned all of these ones. Here it is. There are a couple that we haven't mentioned. This is the symbol for a thermistor. So again, thermistor is a resistor that depends on the temperature. So it looks like a resistor or a variable resistor, but it ends like this, okay? Did I have the light dependent resistor? I don't think it was on the other one. So this one, again, is a resistor that depends on the amount of light. So now you have, instead of 2 arrows coming outwards, meaning light being emitted, now you have 2 lines going in, 2 arrows going in, meaning light is going in. So with a thermistor, the higher the temperature, the higher the current, so the resistance is lower. With a light dependent resistor, LDR, then the higher the brightness of the surroundings, or the higher the amount of light hitting the resistor, the higher the current, so the less the resistance, okay? There you go, the heater again, and finally the electric motor. Alright, we are basically done, but let me just show you here the difference between the cell and the battery. So that's the cell, positive end, negative end, negative end. So a battery is going to be a cell or more, two or more cells together, okay, in series with each other. And here is a representation of the diode. So the conventional way that we say that the current passes through is from the positive end to the negative end. That's actually wrong, okay? The electrons go from the negative end to the positive end, but we only learn about the charges of the electrons after we already have made the assumptions about the direction that the current would flow in the circuit. So we haven't changed it. So we just say that the current goes from the positive to the negative. So in here, the electrons are going through and going in the direction of the arrow, which is the forward bias diode. So there is electrical current and the light bulb turns on. If you keep exactly the same circuit, but you just change the diode the other way around, then now the electrons go in and they hit this wall, so they are opposing the arrow. This is called the reverse direction or reverse biased for the diode. And again, the electric current cannot flow, therefore the light bulb does not turn on, okay? So that is it for today in terms of electric circuits and their symbols. Up to my next video, be happy and healthy. Bye!